With due respect, Dr. Saurabh Chakraborty sir, myself Shoham Gun, I am here to elaborate my CA1 examination presentation on the topic signal and system. Signal. A signal is a means of conveying information through variation in a measurable quantity. Signal can be classified into five different parts. First, time. Second, determinism. Third, periodicity. Fourth, symmetry. Fifth, power contained. Now, under time comes continuous time signal and discrete time signal. Under determinism, it comes deterministic signal and random signal. Under periodicity, it comes periodic and aperiodic. Under symmetry, it is classified into two more parts, that is symmetric or even signal, asymmetric or odd signal. Now, power content, which is classified into more two parts, energy signal and power signal. Now, based on continuity, continuous time signal, analog defined for every value of time. In the left of corner down, I have drawn the graph for continuous time signal. And the example is x function of t is equals to sine 2 pi ft. Now, discrete time signal. Discrete time signal defined only at discrete time intervals. Discrete time intervals means for some specific and breakage of time intervals. In the right corner down, I have drawn the graph of discrete time signal. Example is x function of n is equals to sine 2 pi fn by big N. Now comes based on determinism. Deterministic signal can be described by a mathematical equation and predicted exactly. Random signal. Random signal cannot be exactly predicted, has probabilistic behavior. Means the graph in the right corner I have drawn the random signal graph. You can see that in the graph, the random signal, the stretch of the graph is not uniformly distributed. Whereas in deterministic signal, the stretch is uniformly distributed. Now comes on the next topic based on periodicity. Periodic signal and aperiodic or non-periodic signal. In periodic signal, it repeats after a fixed interval of time. Its condition is x function of t is equals to x function of small t plus big T. In the left corner, I have drawn the periodic signal graph where it clearly shows that the graph has equal edges and equal stretch, and this graph will be repeated samely after a certain time. Now comes aperiodic or non-periodic signal. It does not repeat, it does not have a fixed pattern. And the right corner, I have drawn the aperiodic signal graph, where it is clearly shows that the signal, the graph, is not uniformly distributed all over the x-axis and y-axis. Now comes on based on symmetry, even signal and odd signal. Symmetrical about the vertical axis is known as even signal or symmetric signal. Here, the condition for all capital T is x function of small t is equals to x function of minus small t. For all small n, the condition is xn is equals to x function of minus n. The mathematical form of even signal is x function of t is equals to xt plus x small t by 2. In odd signal or asymmetric signal, it is not a symmetric curve or symmetric graph. It is antisymmetrical signal. Its condition is x small t is equals to minus x of minus t for all values of t, and x function of n is equals to minus x function of minus n for all values of n. Its mathematical form is x naught t is equals to xt minus x minus t by 2. Here in the left corner you can see the graph of symmetric or even signal, where you can see the graph is totally distributed in the same direction, in the same manner in left, whereas in the right axis. In asymmetric or non-symmetric odd signal, the graph is totally opposite. It is neither distributed same nor it has a fixed edges towards right axis and left axis. Now comes the last topic, power content. Based on energy and power. Energy signal, finite energy, zero average power. Its mathematical form for continuous time is E is equals to integration of infinity to minus infinity x function of t whole square dt, whereas in discrete time for energy signal is E is equals to summation of infinity to minus infinity x function of n whole square. Whereas in power signal, the power is finite, but the energy is infinite. Here P is equals to limit n tends to infinity 1 by 2n plus 1 summation of x power function of n whole square. It is the discrete time signal, like same as like periodic signal. Now continuous time signal for power signal. P is equals to limit t tends to infinity 1 by 2t integration of x function of t whole square dt. Here in the right corner, I have drawn the energy signal graph where it shows the decreasing exponential signal. And in the left corner, I have drawn the graph of power signal. So thank you. I would conclude my presentation here. Thank you for your patience hearing.